अरे एक मिनिट एक मिनिट. Welcome back, everyone. We hope you had a refreshing break. You are watching day 3 of Epsilon 2026, and we are now moving into one of the most anticipated segments of our event.
That's right. We now present you our final session under the MTTS track, a panel discussion on the topic power electronics.
Power electronics forms the backbone of modern technology, from electric vehicles and renewable energy systems to smart grids, automation, and consumer electronics. Efficient energy conversion is essential everywhere. With rapid electrification and sustainability goals across the globe, innovations in power electronics, and shaping the future of engineering. To help us explore this advancement and understanding real world challenges, we have invited an exceptional panel of experts from both industries and academia.
Let us begin by introducing our distinguished panelists. First, we have Dr. Ravikant Hiremate, lead R&D and innovative products projects and for automotive applications at Varak Engineering Limited, Pune. He holds a PhD in electrical and electronics engineering and has extensive experience in electric vehicles, automotive power electronics, and renewable energy systems. Dr. Hiremathe has contributed to major EV and defense projects and actively supports academia as speaker, reviewer, and board of studies member.
Next, we welcome Mr. Jitendra Singh, founder of G2Lex, an electronics focused venture delivering innovative technical solutions. His work includes advanced home automation system, custom built industrial machinery, and embedded system solutions designed to solve real world challenges. With strong expertise in applied engineering, he focuses on building reliable and scalable automation technologies.
We are also pleased to have Mr. Tejavat Jagdish, Associate Manager at HCL Tech in energy and utility sector with over a decade of professional experience. An MTech graduate from IIT Madras, he specializes in power systems, DC to DC converter technologies, EV charging infrastructure, smart grids, and HVDC concepts. He actively contributes to academia through mentoring, curriculum development, and technical skills.
Joining us, Mr. Krutik Panchal, a power electronics engineer and R&D professional working in renewable energy and EV technologies. He specializes in high efficiency DC to DC converters, battery management systems, and inverter technologies, and had hands-on experience with simulation tools like MATLAB, PSIM for practical design and testing.
We are also delighted to welcome Professor Vaishali Margulirkar, Assistant Professor at SIS Graduate School of Technology, with over a decade of teaching experience. Her areas of interest include IoT, embedded systems, and sensor networks, and she actively bridges the gap between industry and academia through workshops, expert sessions, and student development initiatives.
A warm welcome to all our esteemed panelists. We are honored to have such a knowledgeable and diverse group of experts with us today.
The stage is now set. To guide us through today's session, we have with us our moderator, Professor Vaishali Mangrulkar. I would like to request ma'am to kindly take over and begin the panel discussion.
Today's discussion will explore industrial trends, technological advancement, and career opportunities in modern power electronics. With that, we officially begin the panel discussion. Over to you, ma'am.
Okay, thank you. Am I audible? Am I audible? Am I audible? Am I audible, students? Very good afternoon to all here for today's panel discussion. Okay. Can you confirm, am I audible? Divya?
या मॅम मॅम तुम्ही ऑडिबल आहात तिथे थोडंसं हे नेटचा इश्यू झालाय 2 मिनिटं मॅम.
ओके ओके फाइन फाइन ठीक है. Okay. Good afternoon to all. Am I audible, speaker?
Yes, ma'am, you are audible.
Oh, thank you very much. Very good afternoon to all here for today's panel discussion on power electronics driving the EV revolution. As everyone knows, electric vehicles are reshaping transportation, and the heart of this transportation lies power electronics, which makes EV more efficient, reliable, and affordable. So, to know about uh, in detail about this, my first question to Mr. Dr. Ravi Kiran, that power electronics is often called the backbone of modern energy systems. From your perspective, what makes it so critical today? Dr.
First of all, first of all, good afternoon to everyone and happy Shivratri to you all. And coming back to the question what you have asked regarding the power electronics is the backbone of modern era. So that is true because why power electronics is the backbone? Because if you see any renewable plant, it needs it, and the all electric vehicle depends on it, and smart grid requires it, and modern industrial process integrates it. So the power electronics is the bridge between the renewable energies and the processing control. If you look into the uh, especially in the electric vehicle, the DC-DC converters regulate the battery voltage, inverters control the motor torque, And if you look into the BLDC motor and motor control area, the all inverters control motor torque, and the onboard chargers manages the grid interaction. And especially in the electric vehicle, the fundamental is switching devices, thermal management, converter topology, and control bandwidth. All these are coming under the power electronics, and based on this we can say that power electronics is the basic backbone of the modern era.
Okay. Anyone want to add something to this question? Mr. Kritik or Tejavat sir? Okay. Then next question is to Mr. I think Jitendra sir. Like, okay. My next question is to Mr. Kritik. Now, looking back, what single innovation had the greatest impact on the advancement of this field?
So first of all, good afternoon, everyone. Like lot of innovations had been carried out in like power electronics field and like into electronics field. But according to me, as far as I have just like gone through the industry and like that, so commercialization of high band gap semiconductor devices such as gallium nitrate and silicon carbide are one of the best single innovations which are carried out in past decades, because they are just working on high switching frequency and like having a like high thermal capability and like that, which gradually decreases the size of other components in the circuits and like that, like passive components and like that. And though it is dominating the industry.
Okay. Now, moving to the next question to Mr. Tejavat. Uh, can you please turn on your camera, Mr. Tejavat? Hello. Okay, fine. You are traveling. Okay, just got the message. Uh, how do the core BMS challenges, specifically state of charge estimation and active cell balancing, fundamentally differ when scaling down from a high voltage EV powertrain to ultra low power wearable devices? So, how the core BMS challenges can, am I audible, Mr. Tejawas? Hello. Okay. No. Okay, fine. Take care. Okay. I think might be some issues. Okay, Kritik, the same question I can continue with you.
Okay,
Am I
ma'am.
audible?
Yes,
Uh,
ma'am.
how do the core BMS challenges, specifically state of charge estimation and active cell balancing,
Yes,
which
ma'am.
uh, which differ when scaling down from high voltage EV powertrain to ultra low power wearable devices? What
uh,
what
so
are your views on this?
so basically there are some parameters which are just observed during that, like voltage, like the voltage and current ratings of the device, cell counts of the device, current level of the device, like type of isolation requirements in the device, and the safety ratings. Like in the like EVBMS or like such system, it requires a higher number as compared to wearable BMS or like that.
Okay, now coming to the next question to Jitendra, Mr. Jitendra.
Yes, yes.
How is power electronics directly influencing EV range, efficiency, and overall vehicle
Okay.
performance, according to
Yes.
you?
So for that, we need to understand one thing, that battery capacity only defines potential range. Actually, what defines the real world range is the work we can do with that battery. For example, in electric vehicles, we need power electronics to actually convert that energy stored in the battery into usable energy, which is used to drive the motors and accelerate the car. So in that process, what happens is the inverter, basically, which is used to convert the DC energy stored in the battery to AC, which is used by the motors. That traction inverter is very essential, essential part of power electronics, which makes an EV feasible to use. Like if the inverter is very inefficient, even though if we have a big battery pack, we won't be able to get a good range with the car. So that's the thing about the battery and the inverter thing. Second part is the DC to DC converter system. For example, we have 12-volt systems in normal cars. We also have 12-volt systems in electric vehicles. So for that, we also need to step down the voltage from 300 or 400 voltage battery systems in electric cars to 12-volt systems. So if that system is also inefficient, then it also hampers the electric vehicle range.
Okay.
Then the next part, yes, I have a last part to say about this. The next last part is about the thermal efficiency. The kind of power electronics we actually choose, even a 6 or 7% difference in efficiency also plays a big part in determining actually what's the real world use case of the car is going to be.
Okay. Okay. Moving to the next question to Dr. Ravi Kiran. How are SIC and GAN devices transforming fast charging and high voltage EV platforms?
Yeah, basically the whatever if you are looking into any of the products, so the all are either the SIC based or GAN based. So the whatever the products are including GAN based, we are seeing it just from some 2 to 3 years. The whatever the GAN devices based products are there, it is taking the market. So if you compare the what is the difference between the silicon and the SiC and GAN, the nothing but so these are like SiC and GAN based devices are higher frequency operations and higher voltage blocking capacity they have and higher temperature operation they have. So if you coming to the especially in the electric vehicle, so the only thing is the main thing is the switching losses and the switching voltage. So the SSC and GAN device has the best thermal performance, and so because of these things, the whatever the current power electronics domain, power electronics domain is there, so they are moving towards the SIC and GAN, and it's almost shifted to the GAN based. So because of the cost and other things, the some of the companies they are using the SIC based.
Okay, fine. So is it cost is more here as compared to silicon based?
Yeah. So like the in the if you compare if comparing with the silicon, the SIC and GAN devices are having the cost, they are having some higher edge of costing, and but as a customer, if it is cost wise, if it is like some 5 to 10 rupees, so it is okay for me. But as a customer, I want to look into some reliability and also some of the warranty and guarantee. So because of the thermal performance and other things, definitely I will prefer the SIC and GAN devices. So because of that, the current like current power domain, it is going towards SIC and GAN based.
Okay, okay, fine. Okay. Can you please all of you turn on the cameras? Mr. Kritik. Okay, fine. I think Mr. Tejawati is having some issue. Okay, fine. Okay, moving to the next question. Okay, the next question is to uh, Mr. Jitendra, beyond EVs, how are charging stations and grid converters benefiting from WBG technology? How can you please take
Yes.
an insight on this? Okay.
Yes. So, for understanding this topic, we need to understand what is WBG in the first place. WBG is an wide band gap semiconductor devices, which are a little different from traditional semiconductor devices like IGBTs and everything. They are in the main core difference in between them is actually the operating frequency and the voltages that they work in. Because of that, they allow ultra fast chargers. For example, if we have used IGBTs and power electronics before, then we may only work around 50 or 60 kilowatt hour charging capacity fast chargers, not more than that. But if we want to go beyond that, if we want to let electric cars owners and everyone, want to let them have that peace of mind that they can charge a car within the comparable time of an ICE vehicle or a petrol or diesel vehicle. We need to go beyond that. So for that, WBG devices allow us to go 350, 400, 500 kilowatt hour chargers, for example. Then
Okay.
because of their fast switching, they take up less space. The transformers used in those devices are quite small. They are also up to 97 to 99% efficient. So because of that, there are very less heat losses, which also enables very cost effective charging. Plus, at the same time, uh, re- mm, very efficient charging.
Okay. Means we are getting more faster charging with the WBG devices.
Yes,
Okay.
faster and cost efficient at the same time.
Cost effective. Okay. Fine.
Yeah.
Okay. Next question moving towards to Mr. Tejawat sir. Am I audible, Mr. Tejawat?
Yes.
Am okay, fine. Thank you. How do you balance innovation, performance, and safety in highly integrated EV architectures?
Can you please come again? I'm sorry. If the question
Okay.
is for me,
Okay. Yeah. Correct. How do you balance innovation, performance, and safety in highly integrated EV architectures?
okay. First of all, thanks for the opportunity to have a discussion in this forum, and I would like to uh, congratulate everybody for being part of this forum where we all come together and share the knowledge. That is where we all gain the knowledge. That's what I believe in. Coming to your question, as an electrical engineer, of course, I'm a part of couple of EV framing policies. Uh, we build the safety into the design, uh, not after use. Or by can what I can say that most of the architectures or electrical vehicles architectures have been built based on ISO standards. In case of automotive vehicles, it can be ISO
Your
maybe 26262. In case of industrial, we do fall under IEC 61501, IEC 61508. IEC 61850 is for that is a different, that is a SCADA protocols. Again, where in the case of uh, like core safety, or I can say that I can categorize safety precautions or safety zones in a two ways. One in core safety and another one is innovation. Where in the core safety we talk about a stable body, and I can say that validating the software which we have built for the modules, which say EV modules. Where in the case of innovation, we talk about how flexible the body, then how advanced it is than the earlier ADA system or any other control system which involved in the architecture of EV. Predominantly, if you can take one example for core protection, for core protection, we do see how standardized it is, and again, whether this the architecture has been passed all the tests which is come under the EV policy framework. And of course, we do see various fault detection systems in the in case of architecture point of view. We do see lot of redundancy in sensors. Of course, we do see watchdog controls. These are part of monitoring our redundancy system, which falls under an architecture part. If you can talk about innovation again, it is a broader area where we have to, or where we have to talk much. Innovation is not just only for the EV architecture, but predominantly, we all might know that earlier, just when EV had just started, at that time, we might do not have much flexibility, or much appliances for the to meet the temperature and all. The slowly, organizations or many industrial organization, R&D institutions have been working on some part of temperature. Some devices has been need to meet the temperature levels and the particular zone. For example, I may say I'm in currently in Hyderabad. I need to meet a Hyderabad temperature. Particularly, I need to design the battery according to the temperature where I am living, or where I am residing into that. So that is what I wanted to convey.
Thank you, sir. Okay,
Yeah,
just
actually,
continuing with, yeah,
just a moment. Sorry for the interruption. So just I
yeah,
wanted to know, like, the Krutik and Jitendra and Tejavat, so they are working in their like no respective companies. So I just wanted to know what are the products you people are building. So just I want to know that regarding this.
Uh, yes, sir. So basically, right now I'm just working as a research and development engineer at Mindra Green. So basically, we are just working on like inverter sections, so on-grid inverters, hybrid inverters, and micro inverters.
Okay.
Yes. So, regarding your question, my company is completely solely based on technical solutions, providing technical solutions to clients. For example, if you have a problem that need to be solved through technology, I can make that possible for you.
Okay.
For your kind information, Ravi Kiran, for your ask, yeah, I am fall under like not particularly one product. What I mean to say that, as mentioned, Jitendra, I'm part of practice and solution teams wherein I work with directly client and customers, wherein what they as per the requirement of the client. It is not like I particularly work on one space. If you can talk particularly, then I can speak much about a DC-DC converter, which is the backbone, or heart of the architecture.
Yeah, like adding to your points, like just I want to know, like, you just mentioned the DC-DC converters. Like, may I know that what are the topologies you are providing the solution and other things? Over to Jitendra and Tejavat.
Sorry, I didn't get your question. Can you just repeat that?
Like no, you just mentioned that you are providing the solutions to most of the companies for their projects and other things. Especially coming to the DC-DC converter, and if you're taking any BLDC motor, like I want to know that what are the topologies you are providing the solutions and other things.
Yes. So my company is not completely based on designing and providing solutions regarding that core level. What I do is I take some technical components, off-the-shelf components, you can say, and then I design. My company basically designs the whole architecture around it to make that problem-solving technology which is required. And regarding your question, regarding DC to DC converters and BLDC motors, in that case, what I can say is core architecture I'm working around right now is silicon carbide. and also some gallium nitride semiconductor devices, not more. Uh, uh, Basically, what my experience in electric vehicles is that I can provide you the current situation of electric vehicles, current situation of electric vehicles in India, because I am a sole owner of an electric vehicle and I do a lot of trips in electric vehicles. The problems facing by the consumers right now, how can they be solved through power electronics, and as well what changes need to be made in the charging infrastructure, in the battery systems, in the complete whole system. That is the sole purpose of my research of buying an electric vehicle in the first place.
What the challenges you are facing while integrating batteries in one?
Jitendra, one more, like, sorry, ma'am, Vaishali, ma'am.
Okay,
So, one more, yeah, like, I want to know, like, so nowadays we heard that Ola is a big failure in EV domain, uh, considering the customer also. So, from your perspective, like, so what are the best companies they are moving ahead in the EV domain?
Currently in India, you are asking, or worldwide?
Yes, yes, currently in India. I'm
Okay, okay.
interested in knowing only India.
Yes. So currently in India, regarding the EV domain, it's a duopoly for now. Duopoly between Tata and Mahindra currently. The difference is every automotive manufacturer is doing things a little differently. Tata and Mahindra both, they are sourcing battery from China, from BYD, and they are getting that battery cells and everything to India, and they are assembling here itself. Mahindra is currently not assembling the batteries themselves, but they are designing the battery and they are ordering from BYD currently. But Tata is currently taking the BYD cells, assembling it and designing it in India itself. And regarding the whole technology thing, Tata is currently a little behind Mahindra in that sense, because of the battery capacity thing, the power electronics thing, and regarding the whole a whole consumer point of view, Hyundai is doing very well. But just Hyundai is not getting, for example, taking the Hyundai Creta. That product is very good. That product gives a range of about 400, which is comparable to a battery capacity of 60, 70 kilowatt of kilowatt hour of range. In that car is giving in 51 kilowatt hour battery capacity. So regarding that, this power electronics in that car is way more ahead on of compared to Tata and Mahindra right now.
Okay, thanks for your response, ma'am. Vaishal, ma'am, you can continue. Ma'am, you are muted.
okay. Moving to this question is for Mr. Kritik. Uh, as integrated power electronic systems are reducing the long-term EV cost, or do they increase initial development complexity?
Yes, ma'am. So basically, shifting towards the power electronics devices and like converters, they are the initial cost is a bit high as compared to other like devices, and if you just go with the basic petrol cars or like that. But according to with the time, they can be like more convenient because the electric generating electric energy and using it is far more cheap as compared to other petrol and diesel engines and like that. So and nowadays, after the heavy usage of converters like DC to DC converter or inverter, or like there are many AC to AC cyclo converters, chargers and like that, they are also used for the charging, which are just uh, very much more convenient to use. And the EV cars are basically charged everywhere. Initially, that was the issue. Like that, if you are just investing on an EV car, then you have to just charge the car at your home. By the charger you are just provided, or like there are some charging stations. But right now, many companies are developing charging stations like at some distance, and like it is quite convenient to the EV users and like that, and it can be like
Okay,
carried
but
forward.
suppose imagine in future
Yes.
all diesel, petrol car vehicles will be converted into electrical vehicles. So what
Okay,
will be
ma'am.
a challenge? What
So
will be a
basically,
challenge in
like
this?
there are certain challenges that's to a electric component, and like it is also having a lifespan. So like to reuse or like to decompose or like how to use that EV waste or like that is one of the biggest issue. But after the usage of like wideband semiconductor switches and like the IGBTs and like that, the lifespan of the device is increasing, because the main issue which an electric circuit can face is like the uh, damage or like the damage done by the heat, because if it's like a high voltage and current, then the heat will be generated, and like heat can just reduce the age of any device. But due to integration of such power electronic devices, the heat generation is drastically reducing, and the size of the enclosure, the size of the devices are reducing. So
So is it all
they
material used in batteries,
Hello.
EV vehicles is reusable?
Hello.
no, everything is not
Hello.
reusable, ma'am,
Come
but
on.
Okay, but
like
how
the
much
One makan.
life
percentage?
like like
One makan sa
but the
bosu.
lifespan of the device can be increased.
Increase.
Kaka Surya answer.
Okay, fine.
Yes, ma'am.
Vaishali, ma'am,
Yes.
that whatever Krutik is answering to your question, just I want to add some more points to that. Coming to an India, it is very difficult to replace all petrol and device related vehicles by electric vehicles. So because the thing is the main concern is the cost. If you look into the petrol and diesel related vehicles with the electric vehicles, it is comparatively it is twice the cost. And one more thing is like what I can say. So in India, we have like R&D should be more and more to reduce the cost. First of all, in the EV domain, and based on that, if you look into some of the news that whatever the Gadkari is telling, he was also mentioning that they are not having any plan to replace all the electrical. So the whatever the petrol and diesel vehicles with the electric vehicles, it is impossible in India, and they're just moving from because of the petrol rate. uh, so as we are observing that the petrol rate is more above the 100 rupees. So based on that, they are just thinking of replacing the petrol with the ethanol, so it should be a
Okay.
cost effective. So yeah, so EV domain is an alternate for the petrol. Because of that only, the whatever the hybrid related vehicles are there, they are coming into demand.
Yeah,
I hope that clears your
yeah,
queries.
correct. Hybrid will work means in future.
Yes, yes, yeah.
Okay, yeah,
You are in mute, ma'am.
again. Okay, fine. Okay. The next question again to you, Dr. Ravi Kiran. Uh, for an energy level power electronics engineer, is it better to specialize deeply in one topology or to have a broader understanding of entire energy conversion ecosystem?
Yeah, like that. Answering to your question, so I can segregate the entry level into two types. The first entry level, it should be coming under 0 to 3 years in between that, and the next phase it will come coming under after 3 years to the some 6 years and other things. So in the entry level, you should have all the broader concepts, like you have to learn buck boost, coming to the resonant converters, phase shifted and LLC and flyback and other things. You have to learn all the all the topologies. And also coming to the basics, you have to understand the physics first, like how the operation is going and other things. And the main thing is magnetic design. for whatever the EE core, whatever we are mentioning, and the toroidal core. So those things are very much important for the entry level the engineer. And also you have to know the how the controlling we can do it for the all the topologies. And also coming to the EMI EMC, it is in next level. So in the entry level, if you are like, you have to understand that how the EMI EMC can be reduced and how EMI EMC will plays an important role in my product and other things. After, like, if you are making all these concept into your study level for the understanding and other things for from 0 to 3 years, and if you are going from after that, you can just focus on one topologies, and you have to understand each and every concepts, like how the, if I'm choosing any of the, for example, LLC, like resonant converter, like what is its effect on the EMIMC, and how I can reduce the EMIMC, and you have to go into the PCB level, and we have to look into the parasitic concepts, and also we have to look into the how I can reduce the switching losses, because switching losses in the sense, as we are using more and more magnetics, the switching losses would be more. So in these concepts, if you are targeting, then it would be helpful for the entry level engineers and in the power electronics domain.
Is it any possibility for the students which are other than electronics background or electronics and telecom program background to enter into this field?
Yeah, so as per my experience, I can say that the every power electronics engineer, he is capable of doing the embedded hardware, but only left thing is software. We know we are in the era of chat gpt and AI. So if I have some YouTube and other things, I can, even the powertrain engine itself will do the software and other things related. So what I can suggest for the ENTC communication engineers, just look into some, because look into the Verilog VHDL related products. So because no, this is, it has its own domain, Verilog and VHDL. So yeah, I can suggest like, so embedded is also additive addition for that one.
Okay, fine. Okay, moving towards further discussion. Uh, this question is for Mr. Jitendra.
Yes.
What role do AI, digital control, and predictive maintenance play in modern power electronic systems? Basically,
Okay.
the role of AI.
Yes. So in that system, what we need to understand is, firstly, in power electronics, how basically what AI is digital control. It's like a digital mind, right? So how can this AI be influencing power electronics? First we need to understand where the AI plays a role in that. So for example, we have digital signal processing units, we have FPGAs, we have the whole circuitry system which actually operates the power electronic system. So what happens in that, for example, in electric vehicles, the state of charge, state of complete state of capacity of the battery is controlled by an electronic system which includes the FPGA. So in that FPGA logic, AI can be used to predict what is going to happen. For example, if I am using a electric car, or if, for in that sense, if I am using any appliance which uses this power electronic system, and over the past few months or past few usages, that whole system can record the data of how that appliance or device has been used, and according to that it can predict how it will be used in the future, so it can accordingly make changes in its own system. So whatever the usage is going to be, it be 100% or close to 100% efficient. I'll take an example for that. For example, if I'm driving an electric car from morning 6 to evening 7, right, the whole day, that in India the temperature will be very high, and the battery needs to be air conditioned so that it maintains a optimal temperature. Normally what happens is when I turn on the car, then the car understands that the temperature is high and it needs to put energy so that the battery gets colder. But what happens if we introduce AI in this system? What will happen is the car will already know that I leave at about 7 or 8 o'clock in the morning. So what it will do is it will automatically precondition the car before me leaving, and automatically this does not require any interference. It will automatically precondition the car, and it will make sure that when I leave from my home, the car is running at its most efficient thing possible. So that's where AI is very important.
How IoT is playing a role in EV vehicles?
EV vehicles, okay. Currently, right now in India, there is no such thing as IoT connected in an electric vehicle or in any vehicle for that sort of thing, because in an automotive market as vast as India, where there is a cutthroat competition for um, making sales and capturing the capture. What happens is the people actually who are buying those cars are driving the companies to provide such features that are essential for those cars. Internet of things, if we imagine it in that sort of thing, the current market of all automotive vehicles, not only electric vehicles, they only consist of one thing, which is remote connectivity through our phone app. What we can do is we can check the car where it is, location wise. We can check how it has been driven since the past few times. We can, in case of electric vehicles, we can check that what's the state of charge. We can check how if the car is on charging or not. We can check how much time it will be taking to charge, and we can perform some remote commands from the phone app. Basically, we can just turn on the AC. Uh, we can log unlock the car, for example. So Internet of Things has not been yet applied at a greater extent in India. But yeah, I can see how this IoT can go ahead in that sort of thing, because in India the market is completely different than how we actually want it to be.
Okay, okay. Next question to Mr. Kritik.
Vaishali, adding to the Jitendra
Yes.
Singh
Okay,
answers, I will add
thank
some
you.
more points so that your query is on IoT in electric vehicles, like that,
Yeah.
whatever the vehicles were. Yeah. So currently, if you consider in my organization, we have different teams. We are working on innovative projects and electric vehicle related chargers and other things. So coming to the IoT, it is definitely now it is booming in India. So if you're considering any dash cam, and if you're considering any of the ADAS, and if you're considering any NFC tag and other things, these and so currently in some of our in other teams they are doing smart helmet also, and they are working on dash cam also. So definitely the IoT is it plays a very important role. Yeah, I can say that IoT is also a good area to work on. Com- uh,
What are the different areas you can suggest for us, for young academicians, uh, to find the opportunities in future in EVs, as like
like
AI, IoT? Is it any other another
no, no,
opportunity? Yeah.
no, no. What is my? So I need a clarity. Like you are asking for the, graduate to enter into
Yeah.
industry or enter into the higher degrees.
Higher degrees, or you can relate with industry as well as higher degree also in both
Yeah,
areas.
in the if any graduate during his fourth year itself, he has to concentrate on as I mentioned earlier only the EMIMC related things, and that whatever we had talked just now, the IoT related things, and embedded and magnetic design, and converters, topologies, And so if he concentrate on these things, and if he takes any project, and if he do some analysis, and if he complete his graduation, definitely he will get into some of the industries where they require these type of skills. So and also along with this one, they have to concentrate on simulation also. So as we know that no MATLAB, and PSIM, LT Spice, so these are the things are there.
Okay.
I'm
Okay.
sorry to interrupt, but I would like to add to that thing. For that, what I can say is, in this current market, in this current situation, if we want a job, if we want students want a job right now, they have to be very aware of what's the situation right now in India, what's the technology, where we are heading, where the technology is heading, and what the companies or wherever they want to work in, whatever whichever field they want to work, they need to research this thing, that those companies are currently demanding. For example, like we just discussed, that IoT is a very good prospect to go ahead in, not only electric cars but also in automotive field generally. That's a future aspect, right? But the current situation is, in if we talk about electric cars, in India, the major requirement for electric cars and the major job opening currently is right now in the field of power electronics, battery chemistry, and general mechanical engineers for body manufacturing. This is the current situation. If we see IoT, it's a future prospect. So students need to take this into mind, that they have to research about the future prospect in whichever field they are going in, and they also have to be aware what's currently going on in the market.
Okay. I agree to this. Okay.
And also the nowadays what the especially students are doing, they have to complete their graduation. For that sake, they are just doing the project for the namesake. So because of that, once after their graduation, again they have to do the hard work, because that so they are spending almost 4 years to complete the degree. Again, for to get into industry, again they have to take some courses to get into the industry, and they have to pay some charges there. So these are the things would be they require. So instead of that, even like for example, if any professors are there or any things are there, they should aware the students with the industrial demands, so that the any of, for example, if you are having the strength of in the fourth year, if you are having strength of 100 students, if out of 100 students, based on your awareness, if any 2 to 3 students are get into some good industries, then it would be a plus for your organizations also. This is what I can suggest.
Okay. Correct, sir. Next to Mr. Krutik.
Yes, ma'am.
Um, how is power electronics enabling large-scale renewable energy integration into the grid?
So basically, like renewable sectors such as wind power plant and solar industries, they are the output of such units are like into variable DC or like that. So to convert them, and because the grid requires a stable AC and a fixed frequency and the controlled voltage to like convert the generated DC from like the windmills or like a solar panels into like a stable AC output. The inverters and like things are used to supply the AC supply to grid, on grid tie inverters, MPPT like maximum power point trackers, and like other things. And rather than that, battery storage systems like battery energy storage systems or battery management systems plays a crucial role in such devices, because there's like many firms are also like storing the energies which are generated from the solar farm or like wind farm. So for that, BMS or BES systems are the crucial part. And like the technology which is used in it is like more into the power electronics.
Okay, anybody wants to add some points on this? Right. Okay, just a question to all. What specific skills are essential for working on integrated EVs and wide bandgap based systems? If anyone can answer for this.
Integration, come again, ma'am.
Uh, what specific skills are essential for working on integrated electric vehicles and wide bandgap based systems?
Like no, that if any if any graduate, if he wants to work in this area, he should have the skills of SIC and GAN based differences with compared to the silicon, and he should have some for example, what I can say that. Power electronics, for example, he should have some skills related with the topologies, and also coming to the what I can say for the integration things. In the integration, like no, just I want to have a clarity here, in the sense of integration with the electric vehicles. In the integration means what you are expecting that integration with the electric vehicles. Just I wanted to know from your
Battery
side.
management system related like that. How the
Yeah,
batteries
battery
are.
management related means he should have he should know some coding. He should understand the coding, and he should have some basic knowledge of battery management system, and how he can do the simulation with the any of the software with any of the current topologies and other things.
As you mentioned, MATLAB or LT Spice, other than any tool you can suggest for the student.
See, ma'am, what I can say tell you for the academics, it is MATLAB.
Hmm.
So if you're
MATLAB
coming to the
is
industry, normally they will prefer PCM and LT Spice,
Okay.
and also some TINA related software is also there. Yeah.
Yeah. All are open source, correct?
Yeah.
Open
So
source can be utilized, used for this.
yes. You can use it.
Yes. Anyone
Yes.
want to
So
add something?
I'd like to add something to that. The basic skill required to actually go into this field is the core basic thing I would say is a basic understanding or a good understanding of physics phenomena. Because if we understand the all the silicon carbide and every kind of topology which exists in power electronics currently, and the whole system, like for example batteries, battery management systems, the charging infrastructure, everything, the designing principles behind all these technologies are basic physics phenomena at play. Like we are just manipulating those physics phenomena, and we are getting those phenomena to do work for us. So let's say, for example, wide bandgap devices, the semiconductor devices, batteries. The students need to understand this key, why the batteries of this specific chemistry, for example, NMC or LFP, and what are the differences in that? What are the voltage differences? What are the temperature variations? And then how to deal with those things if there's a runaway short circuit occurring in that battery, how the battery management system will be able to do take care of that. These physics things they need to understand, because they will be designing a whole system to protect and operate that thing, right? They need to understand this thing. And apart from that, above from that, we can say that they need to understand a little good they need to have a little good understanding of circuit designing, um, what, how, and why the certain components and everything are placed, where they are placed. Not like we are taking this circuit diagram from online, we are just assembling it, or we are just simulating it, then it is working. Not that way. They need to understand why exactly each and every component is placed there, what's their component's role, what they are doing. If we even change this for a similar component, will that work? Not even a simple similar component, but a little different component, will that work? They need to understand this, because in power electronics, optimization is very key.
What are the different research areas as a student point of view, if anyone is interested in power electronics? What are the
Okay.
different research areas you can suggest in
Yes.
future or like?
Yes. So, in future, if we are talking about the market in India, the main point of research would be to go towards renewable, and as well as towards the very high voltage HVDC parts. Because in India, there is a very great surge of demand currently going to happen in the EV infrastructure as well as renewable source. So that's where I would suggest to go.
Okay, thank you all of you. Now we will just start with the question and
Adding to,
answer. Okay,
sorry,
yeah, yeah, yes, sir.
sorry for the interruption, because
Yeah,
I was up and down because of the traveling and the internet. I just wanted to
yeah,
add to Ravi Kiran and Jitendra in this
mm,
perspective. As you have been asking about student, how they need to deep dive into research and how they wanted to take up roles in their initial careers as a power electronic engineer, as electrical engineering.
yeah, correct.
Yeah, I have been, sharing my knowledge, or I have been delivering lectures across South India. About 60 plus talks I have shared, given so far in various engineering forums. I would strongly suggest a student community who are really wanted to deep dive into power electronics or electrical engineering space. Just ask them to start an early third, when they are in a third year, or I can say the seventh semester, the sixth semester, and gateways, or I can say that the entry criteria for this, for them to choose the areas which is predominantly working on the market, alongside uh, alongside the area what they are interested in, instead of focusing on the market. If they can focus on the interest area, so that they can deliver more than what others can expect. Second point, if they are really wanted to deep dive into research, it is better to connect with the professors who are working with industries in, like, not most of tier one institutions like IITs and NITs have been collaborating with various industrial industries, industry key players. So I would strongly suggest student community to interact with the professors, or connect with the professor, or I'm asking them to connect with the professor. I'm also requesting them to write a cold email stating that I am interested into this area, would like to contribute in your laboratory, or would like to work in your research team. Could you please help me out? How could I join with you? I am so and so, I am into this space, I am from this college, I am interested in this area, I have walked through your profile from your website, and you are working in this space. So these are, some of the key things. I know they have been using ChatGPT, Gemini, Copilot, or that XYZ. That's secondary. The primary thing is that they need to reach them in a professional way, so that it is, entry will be very easier for them. And even now, many internship opportunities have been released from various IITs now for summer internship programs. Most of third year engineering students are, eligible for that. I request them to look for all IIT's websites for the summer internship programs, to work under any professor which they are where they are interested in, so that these communication or these relationship helps them to get into their MS programs or PhD programs after their BE or BTech. These are the one way to get into, or be in touch with professor. Other way is, soon after completing their BTech, maybe if they have if they have valid gate score, they can join as a project associate under professors. Maybe they are interested in power electronics, maybe they are interested in power system. That's up to them. But we have multiple opportunities with the gate, not only for joining as MTech, but also we can take up the roles as a project associate. Once we take project associate and you work as a 6 months as a project associate under one professor, after 6 months you are entitled to register or enroll as a MS student or PhD student under the same professor. So there are multiple opportunities that I could say, but all we need to connect with right people so that they can share everything.
Yes, sir. We
Tejo,
will.
thanks for your information. But along with that one, I want to add some more points. the thing is like
Please,
you are
please, sir.
telling about IITs and IITs, the BTech person who is in sixth sem or in seventh sem, he has to write the as a professional way, you has to write the mail to the IITs or NITs professor and wanting to add to his lab. The first thing is no
If they are
IITs or
willing, if they
yeah,
are
yeah,
willing, if they are
that
willing,
I understood.
if they are
That I
willing
understood.
and they are interested.
Yeah. That I understood. That what I
I'm just
as per
giving a
my
tip. I
experience.
am not. I'm
No, no, no.
giving it
Don't
just
tell
a
me.
tip. It is not. I urge or I can say that this is. I'm saying that there is an option that they can utilize. Everybody has their own experience. I would completely respect that. Yeah, you please, continue.
Yeah, the thing is like even if you're considering this Vaishali ma'am also, if she wants to take some students from some other institute, so she will tell like, so even our organization has so many students. Why should I take that student into under me for the any project whatever I am doing the whatever I am releasing the notification. The what my suggestion is that as I mentioned earlier also, the whoever is doing the BTech and other things, they are just in the fourth year, they are just looking into some for the for getting into some industries and just to have some money and other things. So what I can suggest, if he is having that much of a research oriented mindset, what I can suggest them, you just take any of
Go
the
for higher
project.
education.
He's in from electrical perspective, he is from electrical domain or ENTC domain and any domain. So take any of your interested project, do at least little bit of some research. For example, what I can say, if you are taking any of the some project, if you do some any coding, or if you do some simulation, or if you do any little bit of design and other things, so keeping all these things, like because the whatever IITs and IITs, they will take the interns. If you have good basics, if you have strong basics, then they can invite you for their lab and to do some any of the projects whatever they are taking into. And if they are impressed, then they will give them the any of the higher degrees to do under them and other things. And coming to the
Okay,
interns for the BTech people, coming to the interns for the BTech people, so the most of the even for industries also doing now. So they are calling for the interns and for keeping them for 1 year or for keeping for 3 months or 6 months. So these are the things. For the thing is, industry they can groom the students, but in the academics they don't have that much of patience to groom the students. So they are in a hurry to send these students out. So whatever the whatever they have gained throughout this year. So
okay,
from my
sorry to
perspective,
interrupt you,
yeah,
but
yeah,
definitely we will try to go through your all suggestions.
yes,
Uh, we are running out of time, so we are
yeah.
just moving towards your question and answer session. Yes,
Okay.
anyone from the audience having any question, please put it in the chat box. Yes, from the
You can please
audience,
access
just
that.
if you have any queries or question, just put in the chat box.
Okay, so we have a few questions from the audience. So starting off for Mr. Tejawat. So Prathamesh has said this from an industrial implementation perspective. What are the most common challenges faced while integrating power electronics into a commercial EV platform? Sir, I think he might not be available at the time. So we'll move on to the next question. So this is for Mr. Jitendra. What do startups and small innovation-driven teams play in accelerating EV tech development?
Yes. Regarding this, what happens is if we take a wide example, for example, Tesla. Tesla was a very fully grown company before Elon Musk took over that company. But the main difference where the whole game changed for them is when they actually hired people from research background, and actually they hired scientists and researchers from institutes like MIT, and the people who are actually interested in researching about the technology which was required for that. They actually had a complete game changing of their business model. They actually led the whole electric vehicle transition of the whole transitioning from ICE vehicle to electric vehicle was initiated by Tesla. Then because of that, uh, BYD, which was an very small company in China, they also invested heavily in this. Because of their investment, and because of their wide research, for example, battery research, and then they also invested in research of motors, permanent magnet, synchronous motors, and etc. Because of that, they actually got to this current extent that they did get to. So for that thing, if we have an idea, if we know that we can succeed in this, then we have to implement complete, we have to invest completely into that research thing, so that we can actually do that.
Okay, thank you so much, sir. Next, we have question from Tej Raj for Mr. Kritik Panchal. So he has asked, DC to DC converters and BMS play a critical role in EV safety. So what are the key design considerations for engineers that engineers must prioritize? Okay, no worries if he's not available at the moment. We'll move on to the final next question. That is, Sana has asked for Dr. Ravi Kiran. How do you see power electronics evolving with next generation EV architecture? So this has been a question that even I had in my mind while uh, attending this session. So could you please give us a few glimpses of what it could be?
Yes, like the question is, how do you see power electronics evolving with next generation EV architectures? That whatever the EV architectures are currently are
Yes.
there, they are SiC based switches. So now the whatever the current market is there, they are moving towards GAN based because they are having less switching losses, they are having high frequency operation, they are having high voltage blocking. So that whatever we are talking about onboard chargers, we are talking about. So in that case, we are most of the industries, they are moving towards GAN based devices. That what I can suggest to the students to see the power electronics evolving with next generation EV architectures, just as we discussed earlier, understand the physics, and just apply it. For example, if I'm talking about the Ohm's law, V equal to IR, understand it where I can implement in this, where I can implement this Ohm's law. Because for example, what I can see, if I'm talking about silicon carbide GAN devices, the basic, what is the basic difference between the silicon and silicon carbide, silicon and GAN based, and the difference between silicon carbide and the GAN based. So this is the very much fundamental difference. The each student has to know about this. And coming to the switches, and for example MOSFET, IGBT, and even BJT also. First we have to understand what is this MOSFET and IGBTs. And we and coming to the converters, here we have high frequency converters, low frequency converters, high power density converters, low power density converters, and high frequency switching devices, low frequency switching devices, and high frequency magnetic devices, low frequency magnetic devices. So the whatever the EV architectures are there, they built on these basic fundamental key areas. And coming to the next generation EV architecture, you have to, in the parallel way, you have to look into some embedded perspective also, and IoT perspective also, BMS perspective also. So these are the main areas where you can look into yourself. And so the whatever the EV architectures are there, they are definitely they are moving into these areas itself. I hope I have answered to your question.
Yes, sir. Thank you so much. This question was going on in my mind for a long time. Like since we are also EXT students, so we were looking forward ki where we could utilize our knowledge in the EV industry.
And
So
one more
yes,
thing,
thank you so much.
one more thing I want to add here, that that whatever the mindset you are keeping, IITs, NITs people are different from us and other things. The only difference is analysis. If you are taking only little bit topic, so what the student they will do, they are going for whole product. For example, I want to do this, I want to do this, I want to do this. So they're taking so much challenges, and they're wanted to solve. But the smart minds, what they will do, they will only focus on little bit problem, and they will take it, they will analysis more, and they will do the R&D more, and based on that they will improve their knowledge. So this is only the difference, what I can see from the mindset from higher institutes than the lower institutes.
So that was a truly an insightful and thought-provoking discussion. From electric mobility to smart energy infrastructure, today's session gave us a clear picture of how power electronics is transforming the future.
We sincerely thank all our panelists for sharing their valuable experiences, perspectives, and guidance with us.
On behalf of IEEE SISDST, we would like to present a virtual token of gratitude to Dr. Ravikaran Hiramat, Mr. Jitendra Singh, Mr. Tejavat Jagdish, Mr. Krutik Panchal, and Professor Vaishali Madhurkar. Thank you all of being a part of this session and enriching the discussion.
And thank you to our audience for your participation and engagement through the event. Have a wonderful day ahead. Signing out.
Thank you for having us.
Thank you to all panel members.